Alright guys, welcome back to another video, and yeah, today we'll be focusing on differentiation. And yeah, so I've compiled like 3 questions which I thought were quite challenging, and like they were like from like different parts of differentiation. We have rate of change, we have like stationary points, and so on and so forth. Alright, so without further ado, let's get started with question number 1. Alright, so question number 1 is about rate of change. So yeah, let's just take in the information. The first thing we know is like h is equals to 3r, and since we know that volume is equals to pi r square h over 3, if we replace the h, which is equals to 3r, we then have a volume of pi r cubed, right? So far so good. And so if we get dv over dr, that will give us 3 pi r square, right? And so right now we have 3 pi centimeter cubed per second, right? So we have volume as well as time. So obviously 3 pi is equals to dv over dt, right? Right here I do not write down the units, but be sure to write down when you're writing or working, right? So right now they want us to find the rate of change of the radius 9 seconds after the pouring starts, right? So let's just form the equation first. So we have dv over dt will be equals to dv over dr times dr over dt, right? Notice that the dr cancels out, so like eventually we will get dv over dt still, right? That's the main point of the rate of change of equation, right? So if we just plug in the values, we will then be able to solve it, right? So we know that the time that has elapsed is 9 seconds. And with this information in mind, the 9 seconds, we know that per second we get 3 pi, so like 9 seconds would be equals to 27 pi, right? So after 9 seconds, there's 27 pi centimeter cube. And since we already find the volume, which is 27 pi centimeter cube, this 27 pi can then be equated to pi r cubed, right? Because that's the equation for volume. The equation for volume is pi r cubed, and we get that pi r cubed is equals to 27 pi after 9 seconds, right? With that being said, we then can find r, and r is equals to 3. Since we know that the r is equals to 3, we can then find the dv over dr, because dv over dr will be equals to 3 pi and into 3 squared. 3 squared is 9 times 3, and this one is also equals to 27 pi. With that being said, we can then find dr over dt, which is simply equals to dv over dt divided by dv over dr, right? And we know dv over dt is 3 pi divided by dv over dr, which is 27 pi. And then we can get the dr over dt, which is 1 over 9, right? And this is obviously without the units. With the units, it will obviously be centimeter per second. Alright, that is it for question number 1. Moving on to question number 2. Alright, moving swiftly on to question number 2. So for question number 2, we have a 20 centimeter wire cut into 2 pieces, and one is bent to form a circle and the other is bent to form a square. And we don't know, like, it's not stated that it's cut into equal pieces, so we can't assume that. And right now they want us to find the minimum area, right? So let's just say x is for the circle, like x centimeters is for the circle, and so for the square will obviously be 20 minus x, right? And we know that the area for a circle is pi r square and the circumference is 2 pi r. So we know that 2 pi r will be equals to x, right? And therefore r is equals to x over 2 pi, right? And with that being said, we then can find the area of the circle, which is equals to pi r square, so which is pi x over 2 pi square, and that will give us x square over 4 pi, right? And yeah, let's go with the squares now. So we know that 20 minus x is equals to 4L, right? That's basically just the perimeter of the square. So L will be equals to 20 minus x over 4. And so, similarly, the area of the square will be 20 minus x over 4 square, right? Because the formula for the area of a square is just its length squared, right? And yeah, with that being said, we then can find the total area. So if we just get area total will be equal to x squared over 4 pi plus, let's just expand this real quick, 400 minus 40x plus x squared over 16, right? And yep, let's just simplify this real quick. So we have x squared over 4 pi and 400 over 16 is, I calculate, 400 is 25 minus 40 divided by 16 is 2.5, yeah. 2.5x plus x squared over 16. Right, notice that we can group like terms. So right now we have, wait, I forgot to write this. Area total will be equal to x squared 1 over 4 pi plus 1 over 16 minus 2.5x plus 25. Right? And notice that they want us to find the minimum area, right? Regardless if you want to find the minimum area or the maximum area, you need to set the dy dx, or in this case dA dx equals to 0, right? Because that's how you find the stationary point, right? So if we just differentiate dA over dx, we will have 2x 1 over 4 pi plus 1 over 16 minus 2.5 without the x, and obviously the constant will be getting rid of, right? And so if we just equate dA over dx equals to 0, we will then have 2.5 is equals to 2x 1 over 4 pi plus 1 over 16, right? So I think right now it's pretty self-explanatory. We can just solve for x. So if we solve for x, we will get 8.798, right? And with that being said, we can then just easily find the area, right? We can just submit that into the total area equation, and we just quickly do it. And yeah, answer is 14 centimeter square. And with that being said, we have concluded question number 2. Alright, let's move on swiftly to question number 3. Alright, moving on to question number 3. So I think this one's like the typical model we will all be used to, right? So we are told to find the stationary value and determine its nature, right? So we have 2x plus y is equals to 12. So y is equals to 12 minus 2x, right? So we can then rewrite the equation, right? Let's just say this one is z, right? So you can name it any variable you want. So we have z is equals to x squared plus 12 minus 2x squared plus 5x and 12 minus 2x, right? So we have z is equals to x squared plus 144 minus 48x plus 4x squared plus 60x minus 10x squared, right? And so if we just simplify it, let me see. So we have negative 5x squared plus 12x plus 144, right? So if we have dz over dx, because we want to find the stationary point, we will have negative 10x plus 12, right? And so equating dz over dx is equals to 0, so we have negative 10x plus 12 is equals to 0. X would be simply 6 over 5, right? And if we sub 6 over 5 back into this equation, or like the second one actually, to be easier, we then get z is equals to, let me calculate it, right? So we get 151.2, right? So we already found the coordinate. Now we need to determine the nature of this stationary point. So we just we have dz over dx is equals to negative 10x plus 12. That is the first derivative. So we need to find the second derivative. So we have d squared z over dx squared will be negative 10. Right? And remember that if the second derivative is lesser than 0, that means it's a maximum point. So in this case, it's a maximum point. But if it's greater than 0, that means it's a minimum point. Right? And yep, that is it for questions on differentiation. If you have any questions, please leave them down in the comment section down below. I'll be citing all the sources I got these questions from also in the description. And yeah, speaking of which, I also have started like a website for some time now, which has all like very good notes as well as tips, guides on how to nail your IGCSEs, like mainly on like maths, chemistry, and physics. Yeah, and if you have time, I would appreciate if you can check it out. And that's it. See you guys on the next one. Bye.